Okay, this is Rickard Friberg, and from chapter 2 in my microeconomics textbook, we're going to be looking at the change in equilibrium when both demand and supply shift. Okay, so we're looking at a case where there's a market. In this particular example, we're thinking of the market for the metal palladium that's used, for instance, in making catalytic converters in cars. It's also used for a number of other purposes, batteries, etc. But anyway, we have a price of palladium in currency, say US dollars, for the world market. We have a quantity, total amount of tons that are supplied and demanded in this market. Okay, so if we're considering that the market is initially in equilibrium, there's a supply curve, upward sloping as usual, and there's a demand curve, as usual, downward sloping. So lower prices are associated with higher quantities demanded, and higher prices are associated with higher quantities supplied. Okay, so initially there would be we have an equilibrium, there would be an equilibrium quantity, say Q0, an equilibrium price, P0, where the supply and demand intersect. Okay, so now assume that some things are happening here. We can assume that there are tighter emissions regulations, implying that when cars have catalytic converters, other things equal, they will be needing more palladium. More palladium will be used from car producers. Okay, so how does this affect the market for palladium? So as I explained in the book, when we look at what are the effects of a change in the market, we think first, does this affect it all? And if so, does it affect demand or supply mainly? Okay, so here there's firms that are using palladium are needing more. So is that affecting supply or demand primarily? Well, that seems to be affecting demand primarily. Users of palladium want more. Okay, so it's primarily affecting demand. How is it affecting demand? Well, here we can think, it's going to be shifting, right? It's not the price of palladium per se that's changing. It's something is happening to the demand. So one way to think about this is that think at a given price, be here. If a given price of palladium, if producers of cars now want to use more palladium because the tighter emissions regulations, what's going to be happening to demand? Well, at that given price, they're going to be demanding more. And that happens at all the prices. So we can think of demand shifting outwards like this to D1. Okay, you could think lots of things happening, this triggering entry of new mines in the long run, etc. But when we're doing these kind of shifts, typically we're thinking, what's the main thing that's happening here? Keeping other things equal, ceteris paribus, as Alfred Marshall taught us to think. So demand will be shifting outwards. At the same time, assume that a number of palladium mines are closed due to flooding. Okay, so there are really bad weather in some areas where palladium is mined. So is that affecting primarily demand or primarily supply? Well, that seems like a supply issue, right? How much are these mines able to deliver, to produce, to serve the market with? Well, if a number of them are underwater, literally, they're going to be producing less. So that's going to be affecting supply. Again, we think Is it shifting inwards, outwards? Well, at a given price, if a lot of them are flooded, clearly, in total, less will be supplied to the market. Part of the capacity is just underwater. So demand will be shifting inwards, call that S2, like that. And there's maybe we should shift it a bit less if we're to be in line with what's drawn in the book. Okay, to S2 like that. Yeah. So we have a new equilibrium where supply has shifted and demand has shifted. So the new equilibrium here would be the equilibrium quantity of yes, call that Q2 and P2. Okay, so here we've shown a case where both supply and demand shift. In this case, both contribute to raising the price. What are the total effects on quantity? Well, that depends on how much they're shifting. So in this case, if demand had shifted even more, we could have a situation where quantity actually decreased. Okay, so if equilibrium quantities increase or decrease depends on the size of the shifts. How big are those flooding? How many mines are affected? How much tighter are these emissions regulations? These are the kind of things that we're looking at. Okay, so